Hi there, I am your host Dinwant Singh. You are watching Dinwant Computer and Artistic Skills YouTube channel. The topic of this video is flip-flops in digital electronics. A flip-flop is a bistable multivibrator used in digital circuits to store one bit of data. It has two stable states and can switch between them based on input signals. Flip-flops are fundamental in sequential circuits, registers, and memory units. Types of flip-flops. SR, set-reset flip-flop. Made using NOR or NAND gates. Has two inputs, S, set, and R, reset. When S equals 1 and R equals 0, then output is set Q equals 1. When S equals 0 and R equals 1, then output is reset Q equals 0. When S equals 0 and R equals 0, then previous state is retained. Invalid state when S equals 1 and R equals 1 for NOR-based flip-flop. D, data or delay, flip-flop. Overcomes the invalid state of SR flip-flop. Has one input D, data, and a clock signal. If D equals 1 at clock pulse, then Q equals 1. If D equals 0 at clock pulse, then Q equals 0. Used in registers and memory storage. JK flip-flop. Modified version of SR flip-flop, avoiding the invalid state. Inputs. J, set, K, reset. If J equals 0 and K equals 0, then no change. If J equals 0 and K equals 1, then reset Q equals 0. If J equals 1 and K equals 0, then set Q equals 1. If J equals 1 and K equals 1, then toggle state Q changes. T, toggle, flip-flop. Simplified version of JK flip-flop, J equals K equals T. If T equals 0, then no change. If T equals 1, then Q toggles its state. Used in counters and frequency dividers. Edge-triggered and level-triggered flip-flops. Edge-triggered flip-flops change state on the rising or falling edge of the clock signal. Level-triggered flip-flops change state as long as the clock signal is high or low. Flip-flops are fundamental building blocks in digital electronics and are widely used in various applications, including 1. Data storage and registers. Flip-flops store individual bits of data, forming registers that hold temporary data in microprocessors and memory units. 2. Counters and timers. Used in frequency counters, event counters, and digital clocks to keep track of pulses or time intervals. Example: binary counters, modulo N counters, decade counters in digital watches. 3. Shift registers. Used for serial to parallel or parallel to serial conversion in communication systems. Example: ring counters, Johnson counters, and data transmission in UARTs, universal asynchronous receiver transmitters. 4. Frequency division. Flip-flops can divide the frequency of an input signal, useful in clock generation circuits for microcontrollers and communication systems. 5. Control circuits and state machines. Used in finite state machines, FSMs, to manage sequential logic in applications like vending machines, elevators, and traffic light controllers. 6. Debouncing switches. Flip-flops help remove multiple unwanted transitions bouncing in mechanical switches and keyboards. 7. Memory elements in RAM and FIFO buffers. Static RAM uses flip-flops to store bits of data, and FIFO first-in first-out buffers use flip-flops for data handling. 8. Synchronization in digital circuits. Used in clock synchronization and interfacing between different clock domains in processors and communication devices. 9. Digital signal processing (DSP) applications. Used in sample and hold circuits and delay elements for signal synchronization in DSP systems. 10. Edge detection in microcontrollers. Flip-flops detect rising or falling edges of signals, which is useful in interrupts and timing-sensitive applications. Congratulations for completing this video. See you in the next video. Stay tuned.